Hello everyone and welcome to today's video on road design in transportation engineering. In this video we are going to be looking into the concept of road design. We are also going to be looking into the requirements that are involved in road design. We are also going to be looking into the key components of road design and the different types of road that we have. But before we go into road design, we need to have a good understanding of the concept behind this, and that is we know transportation engineering is a sub-discipline in civil engineering that focuses on the design, the construction, and the maintenance of transportation system. And road design happens to be one of the critical components of this because it ensures safe, efficient, sustainable movement of people and goods. So that is one of the reasons why we are going to be looking into this topic, road design, because it's very essential to have a good understanding of what it is, what it entails to design a road. From the word itself, road design, that is, it entails how do we design a road? What are the factors we take into consideration when we want to design a road? And what are the components that we need to understand before designing a road? Before a structural or a construction engineer decides to take up the job of construction, they have to take a lot of things into consideration before designing a road, and that some of those things are what we're going to be looking into in this video. Okay, like I also said earlier, before we can design a road, it has to take into consideration the planning. We have to plan what is the with a lot of considerations we have to take when it comes to the planning. And after when that is done, we also have to look at the designing of the geometric features. How is it going to look like? What is the structural composition of the road going to look like? So these are some of the things that needs to be taken into consideration when designing a road. We also have to look into the structural components of the road. We also need to take a look at the operational aspects of the road and highway. So they are very much important when we want to design a road. We have to design the road in a way whereby where is it going to be, where we are going to be having the traffic. Is there going to be a traffic intersection? Even if there's going to be a traffic intersection, will it be will it be a T intersection? Will it be a roundabout? All these things are taken into consideration in designing the road. So it is very important that the planning and the designing of the geometric features are well executed in order to achieve the goal of the design. So the pre-requirements of road designs. So we know very well that before, when we talk about the pre-requirement, that is, what are the things that we need to take into consideration before setting out on the road design. We know before starting the design procedures of any road, there are some basic traffic related data, whether they are current or whether they are projected for future data, that needs to be provided and taken into consideration in order to determine the basic parameters of the road. And these are some of the requirements of roads design. Then the first one we have here is designing vehicles. We The second one we have is the designing speed, and the third one is the traffic volume. So looking into the first one, which is the designing vehicles, we need to understand the standard type of vehicles that are going to be used as the design control vehicle. So because it's quite important to know the standard type of vehicles. There are some roads, we see some traffic signs on some roads sometimes where it says HOV vehicles or HOVs are not allowed in some kind of roads or in some kind of areas. There are some roads that are designed that cannot withstand HOV, that is high occupancy vehicles, just because of the nature of the design of those roads. So the designing vehicles needs to be taken into consideration in the pre-requirements of the design of the road. So we need to have a good understanding of the designing vehicles. And that is the number one part of the pre-requirements. And the second one is the speed, the designing speed. Yeah, it's more like it's the maximum speed at which a driver can safely drive in a normal weather. So that is what we regard as the designing speed. So the designing speed is the maximum speed. So we have to take that into consideration also. That is when we have this as the maximum speed that the general driver can safely drive in a normal weather, then we can now take that to up in in the designing phase of the road. So because we have to take into consideration maybe things like small traffic density and the vehicle movement is only affected by the conditions of the road itself. So we know this is a normal weather, but in the case of other kind of conditions of maybe road conditions, you should also be able to have a good understanding of how that speed will not affect or lead to any form of casualties in that regard. And the third part here is talking about the traffic volume. And when we're looking into the traffic volume, it is one of the main basis for determining road grade. And in understanding the traffic volume, we know that it's just the number of vehicles on the road at a certain time. So that is how that is the traffic volume. But in understanding, we have to take into consideration some basic traffic volumes like the annual average daily traffic volume. That is, we need to know what is the daily traffic volume, then consider it on an annual basis, the average annual. Then we also need to take into consideration the peak hour traffic volume at the point of the peak hour. In when we want to design this road, will it be able to sustain the peak hour traffic volume? And that is also very important. And the third part is the prospective future predicted traffic volume. Maybe as a result of it is an area where we notice that the population of that area is growing rapidly, and looking at the projection in the next 5 10 years, what the state of the population in that city or in that area is going to be, and the expected number of vehicles that might be on the road. So all this coming together also helps to in the designing of the road. So these are some of the pre-requirements of road design. So we have some key considerations in road design, and the number one consideration here is the safety. That is, we know our safety is very important, and ensuring minimal accident through proper design elements. That is, the elements on the road has to be in a way whereby even if there is going to be accident on the road, it has to be minimal at the minimal rate, the lowest rate. So we have to try as much as possible to make sure the road or the road design is safe enough for road users, whether it be the drivers, be it the cyclists or the pedestrians. The safety in the road design has to be one of the most important factor to consider. So that is why it's regarded as one of the key considerations. Another thing in the road design is the capacity. It must be able to handle current and future traffic volumes. I think I explained that also in the pre requirement of road design. So it needs to have the capacity. The capacity in the road design, it's not just about the present demand of vehicles on the road or the present traffic demand, but on the long run and the future traffic demands on that road. So it needs to be able to manage it, and it needs to be able to handle what the current and the future traffic volume. Another key consideration is durability. When we're talking about durability, it has to be sustainable. It has to be something that can last for a longer period when it is being used. So it must have a long-term usage with minimal maintenance. You cannot construct or you cannot set up a you cannot design a road and you have to keep maintaining the road maybe every 2 weeks or every 1 month or every 3 months. It doesn't work that way. So in that road design, it must have a long-term usage, and the maintenance level has to be minimal. If it's taking a high level of maintenance, then there is something wrong without design or without road. So another factor is, or another key consideration the the environmental impact. That is, it has minimizing the adverse effect on the environment. Whatever road design we have to set up has to have a minimal adverse effect on the environment. We are not looking at it saying that it must have zero. If it is possible to have zero adverse effect, it is fine. But in most cases, we know even if that it might not be possible, but it has to be to the lowest point. That is the minimum, minimizing the adverse effects on the environment. So which can be maybe in form of the carbon monoxide, it can be in form of any emissions and the rest. But the environmental impact when it comes to the road design has to be to the minimum level. Then the next is the cost effectiveness. That is the ability to balance the the economic feasibility of that road. So you need to compare what is the function. When we compare the functions the road is going to be performing and the economic cost of setting up that road, there has to be a good balance between. So if the economic cost of setting up or the economic visibility of setting up that road design is way higher than the function it performs, then we cannot say it is cost effective. So there has to be a balance between the functionality, that is the functions the road design or the road is going to perform, or this we're going to be getting from the road, and also the economic visibility or the cost of setting up the road. So that these are just some of the key considerations we take into consideration. And these are some of the key considerations in a road design. Here we have the key components of road design. And the first one, we have the geometric design, the pavement design, the drainage design, and the traffic control devices. So for the first one, which is the geometric design, under this is where we have the alignment, which can be horizontal alignment or the vertical curves. Here we also look into the cross sections of the road. We look into the lane width, the width of the road. We also look at the shoulders, the lane shoulders have been determined in the geometric design. And in the pavement design is where we look into the material selection. We also look into the thickness design based on the load and subgrades that is under the pavement design. And the third one is the drainage design in that is preventing water accumulation through proper slopes and drainage system. That is the ability to set up a drainage system on the road where whenever there is any, I mean, there is any form of when it rains, or whether heavily, or maybe there is any form of flood, then the drainage design has to be able to withstand, accumulate the water, and drain it off the road as soon as possible for proper movement of vehicles on the road. So this is another key component of road design. The drainage system is very important. The drainage design is very important, and I think in my home country we suffer a little bit from this, because when designing most of the roads in my country, there is no proper drainage system design in place. And that is why whenever there is any form of rainfall, it is usually a problem, because it takes hours, I mean hours, before the waterlog gets to clear off, and it takes, and that causes a lot of traffic congestions on the road, which is not even as a result of volume of vehicles on the road or too much traffic, but all as a result of rain or the waterlog. So the drainage design is very important. And the fourth point here is the traffic control devices, because they are also very important. It's also a key important component of the road design. That is the signage, the signals, and the markings for safe and efficient movement. That is also very important. The traffic control devices. So they help to navigate. They help easy navigation, and also for safe for safety of every road user. So here are the four components of road design. So looking into the road alignment, we know it is more like the direction through which the road passes. So it is the direction through which the road passes. We need to have a good understanding of, okay, when we're talking about the road alignment, the direction through which the road passes. When we understand that, then we can know that if we have a road and looking at what is the direction at which the road passes, then that will help us to have a good understanding of what road alignment is. And under this, we have two types of road alignment. We have the horizontal alignment and we have the vertical alignment. We can see from the picture here, horizontal alignment just talks about the movement when it comes to right and left. But when we're moving in form of grid, then that is the vertical alignment. And here we can see another picture giving a better explanation on this. Sorry. So you can see from the road, most of the roads are not usually in a straight form. So you can see the alignment of the road horizontally moving from left to right. That is why we say the horizontal alignment dictates the left or right turning required to remain on the road. So how to move to the left or the right while still being on the road is more like the is what we call the horizontal alignment. But that of the vertical exert forces on the vehicle as the grade along the road changes. We have the grade on the road when it changes, and still being able to stay on the road is what we call the vertical alignment. And here we can see the movement of the vehicle on the road. So we have it the moment it tries to turn to the left, you can see and still remain on the road. That is what hor- horizontal alignment is all about. But we can see the vertical alignment has to do with the grade on the road, moving from one grade to another on the road, and that is the vertical alignment. So okay, so we have the components of a horizontal alignment. We have three of them. We have the tangent, we have the circular curves, and we have the spiral transition curves. In most cases, we also call it the transition curves. And when we're looking at the tangent, we know tangent is usually more like a straight line. We can see from the first picture here, you can see it's a straight form. The straight form like this, then we can say this is a tangent. This is tangent. So, but most of the time on the road, it has to do with the compilation of all these components in most cases, because not all roads, you can see all roads being tangents, always on a straight line. You see in after a while there will be a circular curve movement or a spiral transition curve movement, like the example we have here in this picture. We can see from the beginning point here, it can be a tangent. From there we have tangent stroke to spiral. Then after moving from tangent to spiral, we have spiral to circular. You can see the to circular. Then we move from circular to circular to spiral, then spiral to tangent, which is a straight line, and goes again. So the movement around this now encompasses almost the three horizontal alignment, that is the tangent movement, because at every point there is always a movement from maybe tangent to spiral, or from spiral to circular, or from tangent to circular. So there is that movement in between. And this is an example. This picture here is an example of a circular curve. You can see, compared to the first one, which is a straight road, you can see here is a circular curve. Like we said, the ability to move left and right and still staying on the road is what we call the horizontal alignment. And you can see from the road design here, this is a circular curve. And from the transition curves like I explained, we can see the movement here, that is the transitional curve here. We have the target point, the transition curve, that is the transition to the circular curve, then from the circular curve again to the target length, and that I already explained in this other picture. Now we have to look into the factors influencing selection of horizontal alignment. So before we decide on which horizontal alignment are we selecting from, there are some factors that we need to take into consideration. So number one factor we have here is the physical controls. And under this physical control, that is where we look into things like the topography. We need to look into the water courses. We also need to look into the geophysical condition, because these are some of the physical controls, or these are some of the physical components that we need to look into before selecting the horizontal alignment, before the selection of horizontal alignment. We also need to have a good understanding of the land use and also the man-made features. What are the man-made features? So all these things are what comes up that makes the physical control. So in these are the things that will help to these are some of the factors under the physical control that influences which of the selection or which of the horizontal alignments we are going to be implementing on that road. So like I said, we have to look into the topography, looking into the water courses, looking into the geophysical conditions, the land use. These are some of the physical controls. And the second is the environmental consideration. We have to be able to know the effects on maybe adjacent land use, the community impacts. We need to know the ecological sensitivity area. We having a good understanding of the the ecology, having a good understanding of the community and the land use. So these are some of the environmental consideration we need to look at when selecting the horizontal alignment. So because in selecting the horizontal alignments means that we have to take the community into consideration. What impact will it have on the community? What impact will it have on the lives of the people around there? And also we need to know how sensitive it is when it comes to ecological use. So these are some of the factors under environmental consideration. The number three thing is economic. When under this, that is what we know. When we hear the word economic, we know it has to do with the cost of something. That is, we have to take into consideration the construction cost. We have to take into consideration the right of way cost. We need to take into consideration the utility impact. We need to take into consideration operating and maintenance cost. So these are some of the factors under economics that we need to look into before selecting horizontal alignment, or the which horizontal alignment we are going to be using. So it is very important to look into the cost in every areas, talking about, like I said, the construction, the right of way costs, the utility impact, and the rest of it like that. And the number fourth factor we need to look into is the safety. We cannot overemphasize on the safety, because has to do with this is a condition that impacts the lives of people. It can lead to loss of life at a glimpse of an eye. At a at a point, everything can it can lead to the loss of life. So we need to have a it has to be safety conscious. That is, it's one of the factors we need to consider. If we notice that a particular alignment will not guarantee the safety of the road users, of the people, then it is better to look into other options. And that is one of the importance of this factor. That is, we need to look at most especially the sight distance. We're going to be we'll take a look into that soon, talking about the sight distance, whether the short side distance and the rest of it. We need to look into the consistency of the alignment and human factor consideration. So we know that when we're talking about the human factor consideration, we know what we call the human error. I think we already explained that in one of the videos. And we also need to have a good understanding that even if this error is going to occur, then there has to be some a level of set up in place that can minimize it, and that is taking into consideration the safety, and that can also be avoided to a certain extent when selecting the which type of horizontal alignment to design or to use on the road. Then the last part is the highway classification and design policies. That is, you have to understand the functional classification, the level of service, the design speed. This is where all these things comes we take all these things into consideration, and also the design standard. If we are going if that design is going to involve HOVs, that is high occupancy vehicles, or if it's going to be restricting HOVs, these all these things has to be taken into consideration. The 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 the, the number of seconds it takes for a vehicle to maybe change direction, it's not going to be the same as that of an high occupancy vehicle. So all these things need to be taken into consideration when selecting the horizontal alignment. Then the next point we're going to be looking into is what we call the line of sight. And this is a very important aspect. Collision is one thing that we have seen over time on the road. We can see vehicles colliding, and it might be as a result of human error. We can take that into consideration. It might be as a result of obstruction, or when a driver is out of sight. When we say out of sight, that is, they cannot clearly see the other vehicle in other parts of the road. We can see, so that is where the line of sight comes into play. We can see here the headlight sight distance. So this is what the headlight can sight. So any other thing out of that range cannot be seen. So this is the more like the line of sight for based on the headlight. And when this driver gets to this point, the line of sight can only range from here to here where the an object is. So this is what the driver can see. But here, this house here is standing as an obstruction, which does not give the driver the opportunity to see what is beyond. But within this worst case scenario, and that is why the the sight distance, or the line of sight, is regarded as the near worst case distance a vehicle driver needs to be able to see in order to have room to stop or avoid something in the roadway before colliding with it. So that is the near worst case distance. So the near worst case distance is what we call the line of sight. We can see here now, this is the near worst case distance between this vehicle and the object here. And from the second picture, we can see here the vehicle here. You can see here is this is the line of sight, the worst case, the near worst case distance you can have. So this driver can see vehicles here. This what he has access to see on the road. But why this building here is standing as an obstruction, because if this building wasn't there, it might have extended the the sight distance of this particular vehicle. So when we're looking into the sight distance, we also have to look into what are the possible obstructions on the road that can help to avoid it. But some of these things are in place, so it is left for the the driver to be conscious of the obstruction, and while also his line of sight while driving. So we have different line of sight. We are going to be looking into the types of line of sight we have. We have the stop sight distance, which is called the SSD. We have the wrong side distance, the meeting side distance, overtaking side distance, intersection side distance, and we also have the decision side distance. Taking a look at the first one, so the stopping side distance. The stopping side distance is more like the shortest possible distance the driver needs to stop when he finds an obstacle he cannot bypass. So the shortest possible distance between the driver and the obstacle is what we call the stopping side distance. And we know from cases, if the stopping side distance is being avoided, or it is too close, that is when it leads to a form of collision. So The line of sight helps to have an understanding of what we call the stopping sight distance, which is called the SST. That is understanding the shortest distance the driver needs or is needed to stop when he found an obstacle he cannot bypass. So that possible shortest distance is what we call the stopping. Then the second one is the wrong sight distance. To understand this wrong side distance, we need to look at a scenario. There are some roads that has two lanes, maybe as a result of the fact that there is low traffic density on that road. So we see in some cases where we have incoming vehicles and another vehicle going in the opposite direction. So rather than most of those vehicles staying on their lane, we see some of them moving in the middle of the road. So when there is an incoming vehicle moving in the middle of the road, maybe on that line, and another one also coming facing each other. Now, the shortest possible distance required for each of them to drive back to their lane is what we call the wrong side distance. We know both of them they are wrong because they ought not to be driving on the in the middle of the road. They ought to drive on their lanes. But since that is not the case and they are driving in the middle of the road, so the shortest possible distance for them to move back to their lane in order to avoid collision is what we call the wrong side distance. So yeah, I believe you have get the idea of this. So the wrong side distance, returning back to their lane, it's very important. So the shortest possible distance is what we call the wrong side distance. Then the third one is what we call the meeting side distance. So still on opposite direction, still an opposite direction, just like the wrong side distance. So when a vehicle is approaching, another one is going, so facing each other or going in opposite direction. Now the shortest possible um distance for both of them to pull their cars to a halt or to stop their vehicles in order to avoid collision is what we call the meeting side distance. So the meeting side distance is the distance required by drivers of two moving of two vehicles moving in the opposite direction and to bring their vehicles to a safe stop after they have seen each other. The moment they can sight each other, they can the shortest possible distance for them to bring their vehicles to a stop or to a halt is what we call the meeting side distance. So it's a little bit different from wrong side distance because wrong side distance is ability of them returning back to their lane. But meeting side distance means that the moment they can see each other, the shortest possible distance for them to bring their vehicles to a stop in order to avoid collision is what we call the meeting side distance. And the fourth one is overtaking side distance. This is just more like also the shortest distance that is open to the vision of the driver of a vehicle intending to overtake. That is where the overtaking side distance comes in. That is trying to overtake. So the shortest possible distance that is open to the vision of the driver to overtake a vehicle, maybe as a result of the vehicle moving in the vehicle is moving slowly, you know, to be able to overtake it safely against maybe the traffic in the opposite direction or on another lane is what we call the overtaking side distance. So you need to understand what is the shortest possible distance, that is the shortest distance open to the vision, which is important, vision of the driver to overtake. So that is what we call the overtaking side distance, and in most cases, is also called the passing side distance. Passing side distance. The next one is the intersection side distance. So this particular one is about the traffic intersection, and we know in a traffic intersection, it's not just about the vehicles. We also have motorists, we have cyclists, we have the pedestrians. So we on the in the intersection site distance takes into consideration the distance a motorist should be able to see all that traffic operating on the intersecting roadway in order to enter or cross the roadway safely and avoid any unexpected conflict in the intersection. That is what we call the intersection site distance. So for the intersection site distance, the motorist should be able to, the shortest possible site to be able to cross the intersection without conflicting or colliding with any other road users or maybe vehicles or pedestrians, is what we call the intersection side distance. And the last one is the decision side distance, which refers to the distance needed for a motorist to detect. It's one thing to detect, is another thing to recognize, another thing to select and initiate and complete an appropriate course of action for an unexpected or other difficult conditions on the roadway. So the ability for you to be able to detect and recognize, select, and initiate, and to decide on what to do. In some cases, the decision making process is just in a split of a second. So it's something that has to be done very fast. So that is what decision site distance is all about. So it's the distance needed for a motorist to detect. When you can detect, there is an accident on the road. Maybe probably you want to swerve to the other or another lane, or you just want to stop the vehicle, or you want to stop the motorcycle. So that's decision, the shortest site or the decision or the distance needed to make that decision is what we call the decision site distance. So we know a lot of things happen within that period. You have to detect, here there is an accident on the road. Then the next thing is to what, recognize you. Okay, what type of accident? Is it on one side of the road? Is it on the two side of the road? If it is on the one side, then maybe you can swift to the next side of the road. Or if it's just on the both sides, so you have to stop the motorcycle or the vehicle. All these things happens in a split seconds in order to select and initiate whichever decision you are going to make within that period. That is what we regard as a decision site distance. Then that leads us to the vertical alignment. Everything that we've still been explaining so far are still under the horizontal alignment. So under the vertical alignment, that is what we call the vertical curve. It provides a transition between two sloped roadways. I already explained that. It said the horizontal alignment has to do with the movement to the left or the right on the road, that is still on the road, and ability to remain that and to be able to manage that on the road. But the vertical alignment has to do with the transitioning between two sloped roadways, allowing a vehicle to negotiate the elevation rate change at a gradual rate rather than a sharp cut. And we can see from the picture here, we can see here we have the flat road, and where we have the convex vertical curve, that is, it's in this form like a U sign. We also have the concave vertical curve, that is, the first one is in the one like an N curve, then the other one is in a U curve. So this is what we call the vertical alignment. So the transition in between it. So from there, we'll be able to move into the type of roads. We have different types of road based on function. We have the types of road based on construction materials. We have that based on location and the terrains, and we have based on the paving status. So we're going to be looking at each of them, from the functions to the construction to the location and the pavement. So without wasting much time, let's move into the first one, which is on function. So based on the function here, we have the expressways, we have the highways, we have the arterial roads, we have the collector roads, and we have the local roads. Yeah, in most cases, people like to pick it from the expressway downward. But for me, in order to have a better understanding of this, if even if you don't, you just know that yes, I know all these things, but I don't know how connected they are or how to differentiate them. So most of the time, I usually like picking it from maybe local roads to the expressway. We know the local road, they serve local traffic, more like provide access to residences or and businesses. So that small road that leads to your house, or that small road that leads to your residence or your home, or leads to your business, is what we call the local road. So but in understanding that, okay, that road, the small road that leads to my house, is what we call the local road now. But for moving now from local road to collector road, so it collects traffic. So the movement of from when you movement out of the local roads will go into the collector road. So when there are movement from the local road will lead into the collector road. So it collects traffic from local roads and channel it to the arterial roads. So what links the local roads or the traffic from local road to arterial road is what we call the collector road. So it is the collector road that links the local road to the arterial roads, and the arterial road is also, we know, is more like the main roads within urban areas, and they connect expressway to the local road. So that is also the function of the arterial road. And the same thing also for the highway. The highway is more like the major road for long distance travel, and in cases you can see them, they have, that is what we have, intersections like the traffic intersections and access points in the highway. But when we're talking about these traffic intersections and these traffic intersections, we don't have them in the in an expressway. So the that is one of the difference between an expressway and the highway, because in the highway, that is where we have high speed roads with controlled access, and at this point we don't have any at grade intersections in the on the expressway. So you can see the movement on the expressway is usually at high speed compared to the highway, because the highway is just like a major road for long distance travel, but still cannot be compared to the highway. Like I said, everything ranges as well. We have it from expressway down to local roads. We can also have it from local road to expressway. I explained that the local road is just the one that provide access to residents or businesses, but the collector road is the one that links the local road to the arterial roads. So that road that links you to us from the that links us from the local road to the arterial road is what we call the collector road. And also the for the arterial roads, they connect expressways to local roads, like said. Then for the highway, we know there are four major routes for long distance travels, and yeah, we have, that is what we tend to have, the intersections or the traffic intersections. For expressway is for high speed roads. It's an um high speed road with controlled access, and you do not find at great intersections there. So this is more like a picture of what, trying to explain, just something to. Then we have based on construction material. We have based on construction material. We have the flex pavement road, and we have the rigid pavement roads. So one of the striking difference between the two, we can see one is flexible and one is rigid, is that the flexible with asphalt, and it can flex with temperatures and load changes. And we can see that this is majorly used in urban and rural roads compared to rigid pavement roads, which is made with concrete and stronger and more durable, but it is very expensive, and it is used in urban highways and intersection. So that is the difference between the flexible pavement road and the rigid pavement road. The rigid is very expensive, but there are some certain part of the road that is being used just on the urban highways. But the flexible pavement is made with asphalt, and you see that on the urban and the rural roads. Then so that is based on construction materials. Then the next one is based on locations and terrains. So the first one we have here is the plain area roads. So from the word itself, plain area road, so that means the areas are plain. And on this type of road, we know they are easier and cheaper to construct because it is a plain road, and maybe it has a very straightforward geometric design. So on a plain road, you can easily go ahead and set up anything there. So the type of road based on location and terrain is the plain area roads, that is on in a plain road. Another one is the hilly area roads. We know these places are more like on maybe mountain areas or maybe a desert. So these kind of roads are usually require special design, because of the structure, because of the topography of those areas. So, and also the steeper gradients and drainage challenges is also another part of the hilly area roads. We've seen on some mountains where some roads are being created on that mountain, and we know how difficult. Sometimes we imagine how was it possible for people to, or for someone or an engineer to be able to design that road, because it's not usually straightforward compared to a plain area road, which is on a on a leveled ground, compared to the hilly areas where it doesn't have a stable topography or gradient. So it can be a little bit difficult, and it requires special design. Then the rural roads, based on the rural roads are more like the one that connect villages with towns and cities, and they usually of lower specification compared to urban roads. So it doesn't really require that much compared to urban roads. All they do is to connect villages to towns and cities. But the urban roads are, they have high traffic volume. We know that it includes additional elements like the sidewalk, the traffic signals. It requires a whole lot of a traffic the system, because of the level of use and the structure of those roads. So these are the type of roads based on the locations and the terrain. Then the last part here talks about the based on the paving status. So looking at that, we have the paved roads and we have the unpaved roads. I think from the word and the picture beside, it's very easy to it's self-explanatory. That is, we can see the paved road is surfaced with asphalt, maybe either with asphalt or concrete or similar materials, and they are usually smooth and durable. But for unpaved roads, they are usually made of gravels or earth or stones, and they are cheaper but prone to wear and erosion. And I know in most villages, you can see a lot of unpaved roads that they are just muddy, and when there is rain you can see the road will wash off, compared to paved roads like we use in modern cities and especially in urban areas. But when looking into towns, villages, you get to see a lot of unpaved roads. Does that mean that we don't have some unpaved road in some urban areas? Yes, we do, but it might just be the outskirts part of those areas, or that or on the in urban areas where you can get to see that. But due to the traffic volume, the frequent use of all those roads, and also the financial situation of or the financial consideration also makes it very easy for paved road to contain all those factors, or probably we having paved road in major urban areas and some rural areas. But based on the paving status that we said here, the paved roads and the unpaved, we can see that the paved road is the ones, any road where we see asphalt or we see concrete or we see any materials on that road, when we can say that is a paved road. And like I said, the difference between a paved road and unpaved road is that they are usually smooth and durable, but unpaved they are not durable. After any slight thing you see, the road is destroyed, and it doesn't really take too much in constructing them, but very difficult to maintain most of the time. So that is the type of roads based on the paving status, and that is all under this topic of road design. And I'll see you in the next video.